Okay, so again, hi everyone, good afternoon. My name is Andre Araujo. I'm a field specialist at Cloudera, specializing in data motion technology. I joined Cloudera about 7 years ago. I used to live in San Francisco, and about 2 years ago, I decided to do something. I used to work in the professional services branch of Cloudera, working as a solutions architect, helping customers. And about 2 years ago, I decided to do something different. And I took this field specialist role, working specifically with data motion. And since then, I have moved to Melbourne in Australia. So the focus of my presentation today is going to be data streaming, which is what data motion is all about. Data that is streaming into your enterprise, into the cloud. And the important thing to realize here is that in today's day and age, the volume of data that we are talking about is a lot. We have a lot of data being generated that we need to process. And to process this data in real time is what enterprises is struggling with. And data streaming is not something that's particular to a given vertical. You find data streaming use cases across all the verticals. So for example, supply chain uses it to collect data from manufacturing facilities directly from machinery sensors on the factoring floor. Retail uses data streaming to collect data about user behavior and user patterns. Utilities collect data from smart meters and so on and so forth. So it's streaming data. I'm going to be talking about streaming data all the way from the edge into your enterprise and using the power of Cloudera Data Flow to enable that and to process that data in real time, analyze that data in real time. As I said, the volume of data that we are talking about here is huge. According to a IDC report from 2020, until 2025, we're going to have 79 zettabytes of data being generated by IoT devices deployed across the world. And this is just a very short time frame. It's less than 5 years from now. So we're talking about a huge data explosion in a very short time frame, and companies need to adapt and be able to process that data in real time. At the same period, the same IDC report predicts that only by the end of that period, only 40% of the manufacturers around the world are going to have the necessary technology and be prepared to automatically collect that data in real time and automatically make use of that information to detect issues and resolve issues in their companies, in their production lines. The data management challenges of data motion are multiple. So we have volume, first of all, which we already talked about. There is a humongous volume of data being generated that we need to process. Second, the velocity with which devices and systems are generating data is unbelievable. Like year by year, like we see more data being generated quicker than before. Third, variety. And here, like if we focus only on IoT use cases alone, we are talking about a plethora of different IoT devices, each one of them generating data in a different format, using a different protocol. And when you implement a use case, you have to deal with those all of those different types of data that you're receiving. And of course, security and governance are of the utmost importance whenever you deal with data, and you need to make sure that you take those into consideration when you implement your use case. So one concept that we like to talk about when we talk about data streaming and the value of data is what we call data decays. So data decays and data has a shelf life. And after some time, data starts to lose its value really quickly. So for example, if you have a business event, and business event could be anything that has meaning for your business, could be, for example, a user walking into your retail store looking for a particular product, or it could be, if you're a manufacturing company, it could be a machine overheating on the factory floor. All of those are business events. So if one of those happens, and if you have systems in place to collect that information, there is usually a latency or a delay before that data is captured. Then you need to analyze that data. And again, there is another delay. But the time you get to the point where you're ready, you know what's happening, and you're ready to take an action or respond to that event, it may already be too late. And if it's already too late, that data that was generated, that business event, has lost its value. So what we want to do with Cloudera Data Flow is bring that action closer as possible to the business event, so that you can reap all the benefits and the maximum value of that data, that business data that you're capturing. So what is Cloudera Data Flow, or CDF for shorts? Cloudera Data Flow is a scalable, real-time streaming data platform that helps you collect the data since all the way from the edge, curate, process, and analyze that data in real time, so that you can get insights about what's happening in your business in real time, and you're able to respond to them in a timely fashion. Cloudera Data Flow is a edge to cloud real-time streaming platform. And I'll explain a little bit more what that means and what it is comprised of. But the important message here is for you to remember that it is about streaming, and it is about real time. Those are the two main concepts that you should take away from this. So Cloudera Data Flow is comprised of three major components. So the first component is what we call edge and flow management, which you can see on the left-hand side here, which is a component that's powered by Apache NiFi. And I'll talk a little bit more about Apache NiFi in a few slides. But this is the component that allows us to get data all the way from the edge into your enterprise, right? In a very efficient and easy way, as we're going to see. Once the data is within your enterprise, we need to make sure that that data is available to all the applications and all the consumers of that data that exists within the enterprise. And that's where the second component, streams messaging, comes about. That component is powered by Apache Kafka, which is a really well-known and proven technology in the open source world that allows messages to be efficiently and very fast exchanged between different applications. So we have now data coming all the way from the edge, from your sensors, from different types of sources into your enterprise, and being distributed as streams through Kafka. Then it comes to the point where we need to analyze this data. So then I introduced the third component, which is called the streaming analytics, which is all this real-time analytics that I have been talking about actually happens. It's powered by Apache Flink, and it allows you to read those streams of data coming from Kafka in real time, analyze that data, detect patterns, and proactively and predictably get insights about your data, allowing you to respond to them in a timely fashion. Right, so all these components is what make Cloudera Data Flow, but they don't exist independently in silos. They are all part of an integrated platform. And under all of those components, there is another layer, which we call Cloudera Shared Data Experience, or Cloudera SDX for shorts, which is a layer that stitches all those components together with a unified security and governance model, so that you can manage and protect all that data in a comprehensive way. You can deploy this on all the three major cloud providers, and also on-prem or in hybrid cloud deployments. And even though I'm focusing here today on data streaming, that's what we are talking about. With this slide, I just want to show you that the bigger Cloudera data platform has other tools or the services that you can use. So you can have a data data engineering. You can have a data warehouse or operational databases, and you can also do machine learning, all integrated within a single platform with the same security and governance controls across the board. For Cloudera Data Flow, we have currently hundreds of customers that use our technology. The ones that you have on the slide there is just a small sample. In preparing for this presentation, I actually got these samples from our website. We have a success story section, and all of these come from there. So if you're interested on any particular vertical or any particular use cases of these ones that are shown there, feel free to go to our website and look for the success stories. There is usually a video or a detailed description about the use case and explaining what was implemented there. So today, since we don't have much time, I'm only going to talk about two of those. So the first one is a company called ClearSense, which is a healthcare company in the United States. ClearSense has been a client of Cloudera for a long time. They used to be a client of Hortonworks before Cloudera merged with Hortonworks. So they have been working with us for a very, very long time, and they're very vocal about the Cloudera technology. They have talked in conferences about their implementation with Cloudera, so they're very good customers of us. So what they do is they do patient monitoring. So their technology uses the Cloudera technology to collect biometric data from devices attached to patients in clinics and hospitals. And the Cloudera technology collects this data in real time and runs that data through machine learning models that have been previously trained. And those models detect when patients are about to experience something bad, like a septic shock or something else. And they are able to send alerts to the hospital, to the clinic, so that doctors can tend to the patient as quickly as possible. So it's a truly life-saving use case where time criticality is really important. So being able to process this data in real time can literally save lives. The other use case is a company called Severstal, which is a steel manufacturer based in Russia. So Severstal produce steel sheets. So they process the ore and they melt the metal and they produce steel sheets. And as the steel sheets are being produced in their production line, they need to analyze the sheets for impurities or defects in the sheet production. So what they do is they have installed all these cameras in the production line, like dozens of cameras that continuously take pictures of the plates, the steel plates as they are produced. And again, the Cloudera technology is continuously and constantly collecting those images in real time and running those images through the machine learning models, which are able to detect impurities and faults in those sheets. And if there is any, an alert can be triggered automatically to the operator that's in the manufacturing floor so that they can do something about that particular plate. The process that they have implemented not only generate alerts, but also generates data that helps them tune the production line. So with that data, they can optimize the production line to maximize production and reduce faults and reduce problems in the production. And what they noticed after they implemented that system was that with very little adjustments to their production line parameters based on the recommendations of the system that was implemented, with like changes of up to 6%, which are not very large changes, they were able to improve the production yearly production of metal by 100,000 tons per year, which is a huge amount. So these are only two use cases. Like we could talk about use cases all day here. There is a lot of other type of use cases that you can apply data streaming, and Cloudera Dataflow can help you with. So just a few examples in this slide. Data movement is all about simply about moving data from one place to the other. It could be like moving petabytes of data from one site to the other or between two servers. From any type of sources in any format to any other destination. And this is what Apache NiFi does well and can help you implement very easily. Logging modernization is another very popular use case with a lot of our customers. One of our customers, large customers in the oil and gas industry, has deployed the Cloudera technology, Cloudera Dataflow technology, to 130,000 devices in their network. So virtually every server, workstation, laptop, or anything that has a microprocessor is now running a Cloudera Dataflow agent to collect data, process this data in real time, and forward that data to the cybersecurity systems that they have so that they can analyze that data to detect threats and intrusions in their network. And obviously the IoT use cases, and here there is like hundreds or thousands of those that we could talk about, but just a few examples like predictive maintenance and asset tracking, which are very common in manufacturing processes, patient monitoring, we talked about in healthcare, fleet management, and connected cars in the automotive industry, and so on and so forth. So let's dig a little bit into those components that I talked about. The components of Cloudera Dataflow. So the first one is what we call Edge and Flow Management. And it has two components. The first one, Cloudera Edge Management. It's all about these small agents that I mentioned before that we can install on the IoT devices or on the devices that are on your edge networks. So these agents, they have a very small footprint. And they are called MiniFi, which is a short name for mini NiFi. So it's a very small NiFi that you can deploy virtually in any device that has a microprocessor. And it can not only collect data right then and there, like in real time from that device, but it also has the capability of processing data in place. So you can filter, you can understand what's happening with that data. You could compress and only send out the core data that you need to implement your use case. So this is what enables us to support IoT use case. And when we talk about IoT use cases, we usually have thousands of these small agents, small devices deployed across your network or across in the field. So you need to have a very efficient way to deploy these agents and manage the agents that are running on your devices. And that's what we do with Edge Flow Manager. Edge Flow Manager is a tool, a central tool that gives you a graphical UI that allows you to manage all the fleet of agents that you have deployed in the field. It allows you to graphically create orchestration flows that are the flows that are going to run on the agent, so that each flow could do something like read the data from the device, parse that data, convert the data to JSON, filter that data, compress, and send the data to your data center or something like that. So you can create those flows. You can select which flows are going to be executed by which agents that you have deployed in the field. So you can monitor the health of all those agents that are running at any particular time. So this, again, is a technology that we have in Cloudera Dataflow that enables virtually any use cases in the IoT use cases and all across all the industries. The other flow management, the other component in this flow management stack is what we call Cloudera Flow Management, which is primarily powered by Apache NiFi. So for those who don't know what NiFi is a data ingestion and data movement engine. It was created about 12 years ago by the NSA in the United States. And a few years later, the NSA decided to make it open source. The core team that idealized and created Apache NiFi later left the NSA and they moved to Hortonworks, which became Cloudera. And they are still working. The main people, the core like brains of that product are still working to Cloudera today, and they have a really strong team based in the United States. So NiFi is this visual tool that gives you a graphic canvas that allows you to graphically and visually build data flows and manage data flows. It comes with more than 400 different processors, which are the units of processing in NiFi. And processors can do anything from acquiring data from a multitude of sources, processing that data in many different ways, filtering, converting format, parsing, routing, etc., and sending the data to other multitude of data destinations. It's very performant, and if you're interested in this, there is a really nice blog in our website by Mark Payne, who is one of the main lead engineers in the NiFi project, that talked about using NiFi to move a very large amount of data very fast. So as I said before, we have tons of customers who are very happy NiFi users. There is a lot of success stories in our website about this, and NiFi can make it really easy for IT folks and operators to set up and monitor those flows in your enterprise. As I said before, once we have the data within the enterprise, we need to make that data readily available for everyone who needs that. So if an application needs some piece of data, they should be able to tap into that data and start using it, provided that you grant them access to that. And Cloudera Dataflow uses the power of Apache Kafka, which is a proven messaging bus, proven technology in the industry for doing that. And Kafka can deliver messages at scale and very fast across multiple applications. Cloudera Dataflow not only ship with Kafka built-in and already integrated with the rest of the platform, but it also ships a whole ecosystem of products or tools that make the use of Kafka even better and easier. So besides Kafka, we have things like Schema Registry, which is a service that allows you to centrally store schemas, which are documents that describe the data that you're dealing with. We have Streams Messaging Manager, which is our graphical monitoring tool for Apache Kafka. It gives you a 360-degree view of what Kafka is doing and allows you to manage Kafka through UI without having to run everything through the command line. We also have Streams Replication Manager, which allows you to replicate data from between two Kafka sites so that you're prepared for disasters and you can provide business continuity if one site becomes unreachable or offline. We also support Kafka Connect, which is a tool that makes it really easy to get data into Kafka and out of Kafka. Cruise Control is a service that monitors Kafka and make sure that your Kafka cluster is healthy and it can react to events and reconfigure Kafka so that it continues to operate optimally. And all these tools are integrated with Apache Ranger, which is this central component in the entire Cloudera data platform, which takes care of managing the security policies. So as I said, we have a unified security and governance layer where you can define security policies across everything that's happening in the Cloudera data platform and comprehensively protect your data across the entire its entire life cycle. And the last component is what we call stream processing analytics. And this is where the magic happens. This is where the actual real-time streaming analytics is actually being executed. The streaming analytics is powered by Apache Flink, which is a modern data stream processing engine that allows you to process, offers you the capability of do real-time analysis of the data with very, very, very low latencies. If you probably have heard of other streaming engines like Kafka Streams and Spark Structured Streaming, which can also do data processing at scale in real time or near real time. But those other systems, they typically lack features that Flink has. So they either lack the low latency that Flink can offer, or they lack stateful streaming, stateful processing support, or exactly one semantics guarantee, and things like that. Flink can also scale to very, very large volumes of data, and this is why you usually see Flink being used in companies that need to process a very large amount of data on a daily basis. Companies like Netflix, Alibaba.com, they have very large Flink clusters, and they're able to process billions of events per day. And we have also added to our product another service, which is called SQL Stream Builder, which is a service that's layered on top of Flink. So Flink is a very powerful and good tool to use, but it's also very technical. So to get the most out of Flink, or to get anything out of Flink, you usually have to have a team of Java or Scala developers. And this team typically talks to your business analysts, translate their business requirement or their questions into a Java program that uses Flink, and then they can submit that job, and that job will execute that process and give the business analysts the answers that they have. But it's typically not possible for the business analysts to do that by themselves because they typically don't know Java and they cannot code using Flink. So what we did was we created this service called SQL Stream Builder, which gives you a UI with a console where a business analyst who knows SQL, or actually for that matter, anyone who knows SQL, can connect to the console and run SQL queries to query your streaming data. SQL Stream Builder will get that query, convert that query into a Flink job, and run that job in real time in your Flink cluster to get the answers that they need. So to be able to use SQL to query data that you have streaming through Kafka and join that data with batch data that are stored in tables, etc., that's a very powerful statement, and that gives a lot of power for business analysts and other people who don't know how to code in Java. So very quickly, just to summarize what we have talked about and give you an idea and understanding of how all this technology is put together. Let's say that you have a chain of stores across your city or country, and all stores have point of sales terminals, which is where the actual transactions happen. I could, for example, deploy Minify, our NiFi agent, and install that on the point of sales terminals or close to them, for example, in a gateway that I have for each store. And those agents, they could collect the data from those point of sales terminals in real time. And in real time, they could actually process the data in place to understand what's happening at the store, understand the transactions that are going through, and understand how they affect the store revenue and the store inventory, even before the data leaves the store. Then depending on what you want to implement, the use case that you implement, that agent can summarize that data, and that summary can be collected by NiFi that you have running centrally in your data center. NiFi could do things like aggregating that data regionally and making that data available in Apache Kafka. Then from here, I could have a process running on SQL Stream Builder or Flink that reads that data in real time and produce insights, produce actionable insights for you so that you can take action as quickly as possible. From here, I could do a number of things. I could send some of that information to Cloudera Machine Learning to build or enrich models that I have, that I'm working with. I could store the data somewhere else, like in an OLAP database or in time series stores, key value stores for other types of uses. Or I could use data visualization with Cloudera Data Viz to create, for example, real-time dashboards and understand what's happening to my data. So all of this and all the Cloudera data flow has led earlier this year for Cloudera to be classified as a strong performer by Forrester in the Forrester Wave for Streaming Analytics that was published earlier this year. And I think the key factor here that got us there is the comprehensiveness of Cloudera data flow. That's not only like a data ingestion tool, that's not only a messaging bus or a streaming processing engine. Cloudera data flow gives you all the tools that you need to get the data from the edge all the way to your enterprise or to your cloud and process that in real time and generate real-time insights for you. And that's the power of it. And that's what I try to convey here in this presentation today. You see that we were just short of the leaders wave, like we're strong performers, but at the upper boundary of the strong performers. We believe that it's very clear for us why we didn't go into the leaders wave. And we believe that by now, so this was published in Q2, and we believe by now we have already put in place in the product all the things to close those gaps that got us short of the leader wave. So we're pretty confident that in the next wave that's going to be published, our position is going to be much stronger than it is today. By the way, the report is available in our website, so you can go to the website and download the full report if you're interested in this. And with that, that's all I had to present to you guys today. Happy to take questions if there are questions. Thank you very much.